All right, it is time to go over OpenCore and a complete thing. You want to install macOS on pretty much any PC hardware. This is what I've done, and it is a fantastic piece of software. Everything is free and open source in this video, so you're either going to be downloading directly from GitHub or directly from Apple's website. No torrents or any kind of illegal downloads at all from this one. Everything's open source, and again, from official repositories. Now, I will be creating this media using a live USB called Linux Mint. And Linux Mint's great. It's an easy way to get started. I'll go ahead and link a video up here. It's a simple USB drive that you make, and you can just plug in. If you're familiar with using USB drives to boot into a live environment, it's very simple. I use Ventoy, but Ventoy is Ventoy, and you can put any ISO on it and it'll just boot from it. So great to have for multi-booting, to install Windows, to install Linux, whatever it might be. But we're not installing. We'll just have the Linux Mint ISO on there, boot directly to it, and then do this entire setup within this live environment. The reason for this is so we can basically have anybody do this. You don't need a Mac to get started with this, and it works great. So with all that said, let's stop talking, get on the desktop, and get this thing done. So booting directly from my USB drive, I'm just going to select my Linux Mint, install, and we're going to boot directly into Linux Mint. Now, Linux Mint, we'll use this one. Now, you don't necessarily need to use Ventoy. You could just format Linux Mint using Linux Mint's tools if you like. All right, and we're on the desktop. Obviously, don't install Linux Mint. I'm just saying let's use it as a live environment. And I've created a little cheat sheet for everyone to follow. So if you get lost here, just know this is how, just an easy way to get started. So if you go to christitus.com and /OpenCore-Mac, that'll bring you right to this page. I'll put the link in the description. So if we scroll down here, you'll see everything. Why OpenCore? I just went over that with it being open source and basically indistinguishable, using all official sources. I love that. Hardware compatibility, what can't you install on a Mac OS or can't use on a Mac OS, I should say. And it's simply NVIDIA cards is a big no-no. If you have an older version of NVIDIA, like the 900 series and before, you can use an older version of Mac OS up to High Sierra, which is 2 versions behind, which is 10.13 for those Mac OS users. And then also Intel wireless cards for those laptop installs. They're very prominent. They're all over the place, but they don't work for anything in Mac. I've hacked around and gotten some kind of working, but it's really bad. You need to buy a new wireless chip. So the cheapest way to do this is to buy an old used MacBook Pro Wi-Fi chip and then just get an adapter off Amazon. Usually each run about $10, so you're out about $20 for that solution. If you want a more traditional all-in-one solution and just have hardware that works on any PC, I highly recommend the DW1560 wireless card. It's about $100 brand new, $50 used. You can do that as well. But those are really the two big things that just are kind of gotchas with macOS. But with that said, you can use AMD hardware with OpenCore, where Clover and all the past ones don't support it anymore, or it was kind of hacky to begin with. Where OpenCore is just natively, you can put a 3950X on here and just be like the most powerful Mac in the planet. It's amazing. So if you want to go that way, you can. However, I'm going to be using the Intel hardware for this video, and then we're just going to collect all of the stuff. I've made little links for everything you need to download. So I'm just going to open up all of these, and we're going to download all 4 of these projects, and then we're going to collect all the drivers that we need. And then there's a checklist. Basically, this is an OpenCore desktop guide. Check compatibility, done. Download all projects and files. Let's go through all of these links and download these. So we'll just go into here, download the official release, save, and close that out. Do the same here, just download zip, and we'll just continue with the rest of the projects here. And then when we get to gathering files, we get to our desktop guide. A couple things we need is HFS+. We'll just click download. Open Runtime actually comes with that package we just downloaded. We're not going to need any legacy files here. I'm using like an 8-year-old hardware, 7 or 8 years old. It's an old Haswell chip. And I didn't need any of this legacy stuff. So mileage will vary here. Just read and see if you do qualify for any of these. I don't. We'll download these 2 packages. So again, more downloading. We'll grab our graphics. And for the chip, you might not know what chip you have. Just pull up your terminal here, just the terminal in the lower left, and then you just do LSPCI. And you'll see Ethernet controller, that's our network adapter. And this is an Intel Corporation Ethernet connection i217. So I know it's an Intel chip, and we can go from there. So we'll grab the Intel one for all Intel NIC cards. So boom. And it's even based off the i211, which is very close to this chip, so it'll work just fine. We'll download that. Now, obviously on here, if this said like Realtek, 1111, then you download that corresponding kex. Don't download all of them, just the one for your computer. USB, a lot of people use USB inject all. I tried this out and I didn't need it. So I actually just ended up deleting it. However, if you do have USB issues, try this one and then go from there. I didn't have any issues. I don't have Wi-Fi or Bluetooth in this PC. I'm not using AMD for this one. And then the rest of this, I don't really need. There is one thing in here, and it's called Voodoo HDA. Right here, it's actually says AMD CPU. I have an Azalea Intel chip for my audio, so I actually needed the Voodoo HDA, which I'll go ahead and download. But if you use the Voodoo HDA or you have sound issues with Apple ALC, just know you should probably go ahead, delete Apple ALC, install Voodoo. But again, mileage will vary. Your system is not the same as my system. So just know that you will either use Apple ALC or Voodoo HDA for graphics cards. Or if you see HDA errors or audio-specific errors on your boot up, you'll probably want to swap out one for the other just to try them out. That's all of the file gathering. Let's go ahead and create our base file system. So we have all these. I'm going to go ahead and put all the kex in one folder, which is our drivers that we just downloaded, and then the projects in a separate folder. So we're going to go 1, which will be kex. So as far as driver packages, we only have 5 packages, but we don't need everything that's in these packages. So I'll just take these, highlight all of them, extract here, and then we're going to clean this up some. So we'll delete these zip files, and we'll just come down into here, grab our anything with .kext. We won't need anything else. So we'll just delete that and kex. Now in virtual SMC, there's a little gotcha here. If you're using a laptop, you will need battery manager and light sensor. However, if you're not using a laptop and using a desktop like me, you won't need either one of these. So you only need these 3 in this instance. So we'll come back into here, paste that, and we can easily get rid of that folder. Moving on, Lilu, again, we'll just grab that, come back, paste, and delete that. And then finally, our Intel chip for our Ethernet, and we'll delete that. So that's all the kex drivers we need for this particular system, but that's how you'd pick it out. Notice how I didn't just grab everything. I specified and got, okay, I need this, this, and this, and there you go. Some of it is trial and error. For the audio, I tried both. I first tried with Apple ALC, ran into a lot of HDA errors, and then switched over to Voodoo, and all of them cleared up. So just depends on what you're using. Although this is whole hardware, so Apple ALC will probably work for most of you. All right, so now that we've gathered all the files, I think we can go ahead and create our USB drive. So first off, let's go ahead, go into our terminal, and we're going to do an LSBOK. I'm using a 4 gig disk, which is SDC and SDC1. So we'll just do sudo gdisk dev /SDC. You don't need a number 1 or anything after it, just SDC. You may see just MBR present, but what you'll do is just do O. This will delete everything on the disk. Hit yes, and that's done. And then we're going to do new and partition. We're just going to enter, enter, and then we're going to do 0700, and this is pretty much finished. So we'll write this out, and we'll say yes, and then we'll quit, or actually quit for us. So now if we do an lsblk, you won't really notice much of a difference, but you may notice on your system, and we're ready to basically use this and write to it. So before we mount this disk, we do need to go ahead and format it. So on the Linux install, we'll scroll down, and under method 1, that's everything we just did, and all we really need is to make this right here. We're going to go ahead and copy this. Make file system vfat. We'll take it, paste that in here. To paste into your terminal, you can either middle mouse click or do Control-Shift-V. So we'll go /SDC1, and this will go ahead, format this. If it says, hey, this is already mounted, notice you may need to do a umount dev SDC1, and then it would unmount that. But you can't have a mounted thing and format it at the same time, just a word to the wise. So with that done, we can go ahead, exit this out, and this disk is pretty much prepped. However, let's get to our projects and start downloading Mac and populating our boot disk. And again, if you get lost during this, I made this little checklist. So we've checked our hardware compatibility, we've downloaded all the projects and files, and now we're booting and making the DSDT dump and all the other stuff associated with it. So number 3 is, there's a lot going on here. So we've already formatted our USB drive, and now we're going to start making stuff. So the first thing we need to do is the gib macOS. We're going to go ahead and extract that here. I'll delete that. And then we're going to need to run this command and go ahead, launch into it. So I think we need to install Python first. So we'll do mac install Python. We'll do a listing, and then we'll do Python gib mac os.command. All right, from the gib mac os, we'll go ahead and type R for recovery mode only, as since we're not in Mac environment, we can't create a full install of a Mac disk, which is okay. We can just do a recovery disk. That means as we install, it'll download all the updates and everything it needs to install Mac. We're going to choose number 1 here for Catalina 10.15.5. Notice this is only 500 megs, so it doesn't take long, and I kind of like this method better than the full install anyways. The one caveat here is you need to make sure you have a working internet connection before obviously this will work. All right, that is finished, and we'll just quit. I went ahead and quit it out, even though on this, as you see, down towards the bottom, you have this command to run. This can get a little cumbersome, so I just grab this one little command, and then I go all the way down into where that actual download package is because it's a really long path name. It's hard to find, so we're just going to right-click an empty space and say Open in Terminal, and then we're just going to paste that command in, close out. And these are the files we need for the next system. So in our OpenCore USB over on the left-hand side, as you see, there's nothing in this USB drive. All we've done is formatted it, made an EFI partition, or the partition as it said right here. So the rest of this I'm actually going to do within here. So we're just going to do com.apple.recovery.boot. And we'll open this up. And then from our downloads thing, we can just paste those 2 base system files in. So we'll hit paste. It downloads and pastes the base system chunk list and the base system.dmg. So we've pretty much got the boot partition done, but now we need to make sure that we get all our drivers and everything associated with the system in and install OpenCore on our boot USB. So we're going to extract OpenCore next. We'll extract it here. It extracts 3 directories. We'll go into OpenCore. You will not need docs or utilities. In the EFI directory, this is what we need to actually take over into our OpenCore USB and paste it into here. Now, before we start adding stuff to it, we actually need to clean up this EFI one. And the best way to do it is adding the base files. It shows you exactly what you need to do. There's so many extra files added here. tools and things that you're just not going to need. So let's go ahead, clean all this up real fast. So we'll just go through the OC directory, go through each one, just make sure. Drivers, you don't need anything but the open runtime, delete. Kex is empty, but it's not going to be for long. And then under tools, all you need is OpenShell. So we'll hit delete. So now all we really have are these files that are highlighted in red from their file. So now you can see I've mirrored everything from the folder structure. So now that we've deleted everything we need to delete from OpenShell or OpenCore, we can actually go into here. So I'm actually going to go ahead and put this on the left-hand side and open up a new tab in the downloads. We're going to grab all those Kex from earlier that we've already nicely situated, and we'll paste this in. If we open this up, you'll see all of this. Notice everything ends with .kext. If you put folders in here that aren't .kext, it's not going to read whatever's in that folder. So obviously, this is the exact structure. And if you're unsure of what that Kex looks like, it always has the same structure. So if you open these up, it always has the contents folder in there. So if you open one up and it doesn't say contents, it's not a good Kext. Delete it. You're going to only cause problems for yourself, or at the very least, it's probably just not even going to load. So there's one more file, and that's the ACPI. They do have pre-builts that you can use. These are slow, cumbersome. You're going to have long boots. Your system's not going to work as well. So I don't like this way. The whole reason why I told you to boot into the Linux Mint environment is simply this. There's a cool little project from the downloads folder, if we look, called SSD Time. So let's extract that here, and we're going to go in this Time Master, open terminal, and then we're going to just do Python, and then we're going to do SSD Time. And we'll go ahead and hit enter here. And right now, we don't have a current DSDT. What is that? It's basically a dump of what is your hardware all about. It basically shows you all the hardware stuff. So the very first thing we do is number 4 for dump, and we hit enter. And then you notice that the current DSDT is now filled in. And then we're just going to go 1, 2, and 3 and just go through and create what's called SSDTs. So we're going to go 1, and we're going to go ahead and hit enter, enter, number 2, enter, number 3, enter. And that's it. We just created our DSDT and all our SSDTs, which basically just tells Mac, hey, this is what hardware you have to work with. Here's where everything is. And it makes it really easy and very universal. So you can do updates, you can do everything that you need to do instead of changing, the actual system itself, like some of the old hacky ways of doing this. So we'll close that. Under results, the only thing we need from here is the SSDT AML files. So we're just going to grab these 3. We got SSDT, HPET, plug, and EC. We'll go ahead and copy these. And we're going to paste those into the EFI, OC, ACPI folder. So we'll paste all 3 of those in. And every file is now set in this thing. Now, we do still need to make our plist and kind of start configuring all the options for the boot device. Now, if you do have problems with the ACPI, in that getting started with ACPI, there is a hard way of doing this, and it basically maps whatever you need to map to make it work. This is very complex, way outside the scope of this video, but just know this is the resources you go for. The thing I love most about OpenCore is there's just all these geniuses that, 1, have a fantastic project, and 2, do a great job with documentation. I think anybody could figure this out. So now we're on to config plist setup. And we're going to download the config plist for whatever whatever system we currently have. So if you're unsure if you have an Intel Haswell, Skylake, Coffee Lake, whatever it might be, simply open up your terminal, and we're going to do LSPCI. And you can see right here, it'll say 4th gen or 3rd gen or 8th gen, whatever it might be. And it may even say Haswell, depending on what tool you run, but for LSPCI, it usually tells you what generation of chip it is. Not series, but generation right here on the host bridge. So let's go to Haswell, and we'll see right here, everything here, starting point. We'll need proper tree, Gen SM BIOS, which I don't think we have. Let's look at our downloads folder and make sure we have that project. And then just a sample config file. So let's grab that as well. It's actually in the OpenCore. Under docs, I forgot to grab that. So we'll just copy that. So if we go back into the OpenCore EFI OC directory, we can just drop that sample plist. And then we're just going to rename this, not sample, but config. And then we can start with the good stuff. Now, this whole portion, once you get it, you're going to need to walk through each one of these steps. So I'm going to actually pull in that sample plist file, and we're going to go through each individual one. Now, if you did have problems in the previous step with ACPI, there is pre-builts you can use. I want to reiterate that. It's just going to, cause issues with performance and also long boot times. So if this SSDT time things didn't work for you, you could always download a pre-built, but I just don't recommend it. So to start off with, we're going to just pull in that downloads folder, and we're going to go ahead and extract proper tree right here. And we're going to also need GenBIOS once we're finished with proper tree. So we'll extract that here as well. I do have a HFS plus file. Let's make sure that that's in the proper place. Anytime you have just EFI on the end, make sure all your EFI or .EFI files fall into your drivers directory. I forgot to add that, but that's just oversight on my part. Always double check that gathering files section, as I noticed that extra one. I like to delete as I go just in case there is a leftover file. I'm like, wait a second, did that copy? And then obviously it didn't on that regard. So from proper tree, we need to run this proper tree command. So we'll just launch back into terminal. And then we'll just do Python proper tree. Notice it is case sensitive. Now, in this regard, you'll notice that it's giving me an error. It says, hey, file line 10, import tk enter as tk, no module name tk enter. So to solve this, we're just missing a dependency. And not very clear with that error message, but this might save you. Just go python-tk, hit enter, and then we're going to rerun proper tree. Python proper tree, and now it launches just fine. So this is the program that we use to really build all of our stuff. So we're going to go File, Open, and if we go to the root directory, Media, Mint, OpenCore, EFI, OC, config.plist. A little bit of a mouthful, but that'll get us there. And here we go. So we'll start with these warnings. We're just going to delete all these guys. You don't need the top warnings. And now we need to go ahead and do OC snapshot. This is going to fill in all of the stuff we need. So we'll OC snapshot. We'll go ahead and select that. It was kind of hidden behind this folder. So if it does, just make sure you select OC folder down there. So media, Mint, one more time. Go through all of this folder structure and hit OK. You'll notice it kind of cleared out a bunch of stuff. And then I like to do, at the very end, usually you do an OC clean snapshot. This just kind of cleans it out. We'll go ahead and hit OK. And it also reorders everything in the proper order it needs to be. So first you load the snapshot, and then you do a clean snapshot. We have everything loaded up. Just look for any issues or quirks, like rebuild Apple memory map. This says it needs to be yes. Let's go back into here. And if we go down to quirks, this is done, but we're in the booter section. So as I do stuff, we're done with ACPI. I like to minimize. And then I kind of go through here, rebuild app memory map, just go to true. I know that's good. Is there anything else that we need to do in our booter section? And it looks like there is. So what I'm going to do is we're going to just put these side by side as we go and go to quirks under that. Avoid runtime defrag, true. And this says yes. Provide custom slide. That is also true. Rebuild Apple memory map, we just did. And then set virtual map right here. So all that's set. So this is done. We can move on to device properties now. So minimize that. Device properties. So in this section, there's a couple things. You'll notice that we have just this one, which does not match this. So we need to actually add this device. So we'll go ahead, right click under add, say new child. And we're going to go ahead, put this in. So under here, we need to start adding stuff. We can't do that when this is set as a string. So we double click and say it's dictionary. Now when we right click, it'll say new child, and we can specify what we need. So we're going to do the Apple IG platform ID. We'll copy that. We're going to come back and fill in these values as well, but there's more stuff to do. This is the default integrated GPU used to drive the display. So we'll go ahead, copy it. If you had an iGPU only, but doesn't drive the display, you could put that in. And if you had a Broadwell integrated iGPU, obviously we're Haswell, so obviously Broadwell does not apply to us. And we can just put this one in. And if you're unsure of what that is, it's usually a data type. You can look at the picture to kind of match that up. So we'll go data and then fill in that value and then move down. Next up is going to be device ID. So we'll right click and we need a sibling for this guy. And then this is the device ID for HD 4600. And if you don't have an HD 4600, obviously you probably need to look up your device ID, but it so happens that I do have on this one. So we're going to go data. And then we need to add 3 more properties here. Framework patch enable, stolen memory, and FB memory. So we'll go ahead and add these in with the corresponding values. All right, and all that is good. So we're pretty much finished with this section. This is an example of this. You can see kind of the examples for each one. If you have one of these that is specific to you, you can kind of look to see how they change. And if you don't see your platform or device ID, be sure and look that up online. It would not be listed here. All right, so this is done. Device properties, now on to the kernel. So kernel, you'll see under quirks is really where we need to change some things. So let's take a look. But under quirks, we got a lot of stuff to change. So we'll go through and mark all of these, match them up. All right, and that is finished. So we're done with kernel. And now we're on to miscellaneous. We're just going to kind of continually going through. You kind of get the idea here. Everything has a place. You need to touch every single one of these keys. So I don't think I need to continue on with this. You get the idea, but just make sure you get the proper chipset and you go through, you match up everything. And at the end of the day, go in here, verify everything's good, but also take note, like in this section where it says Apple debug, yes. Apple panic, yes. You can actually go through and disable these after the fact. So you enable them for some of the debug purposes when you're installing, but once you're done installing, you come back and just say, you know what, I don't need to debug this anymore. And I just want my system to boot as fast as possible, and I just want to see that lovely Apple logo with nothing else. And this is where you'd go through and say, change these back to false so you don't debug, or you don't need the debug. So after you've gone through the entire file, you'll just simply go save, and then you can exit. So then you can quit after saving. There is one more thing we need to do, of course, before we restart. And back into here, we're going to go into our downloads directory again, as there's one last tool we haven't done. We've done proper tree. Now we need to generate a serial number to identify this Mac. Depending on what GPU or what series you are, it kind of gives at the end here of SM BIOS what you should do. So for this, it's a Haswell GPU. It's integrated graphics only, not dedicated. So it'd be 14-1 would be what I'd want to use. So again, we're just going to do Python and then gen sm BIOS, and then we're going to just install. This downloads all the stuff we need. And then we're going to select our plist, and it says drag and drop, but I think on Linux it does not quite work on the drag and drop, but that's okay. I'll show you how to get around that, as we're just going to go to where our plist resides, like right here. Just click in the header, and then we're just going to take this entire thing. We'll put a single quote, paste that in, and then just type config.plist, and then another single quote to end it out. And then you'll see it pulls in our plist. So now we need to generate the SM BIOS. So we'll go number 3. And this is where we need that in here. So we'll go copy and we'll just paste that in, hit enter. It generates all the serial and board serial and everything we need, hit enter, and then generate the UUID, enter, and then simply quit. And now we are ready to reboot into this boot device. So let's go ahead and do that. All right, so we're just gonna come down here, hit our power, restart, and now we can remove that Linux Mint USB. I still have the other USB in. We'll go ahead and hit enter and select it on startup. And then if we press F7, you'll see that OpenCore file that we just did. We'll go ahead and select that one. So we'll just hit OpenCore. And then we get to select everything. You'll want the DMG external. Sometimes this is called different things, so it just depends on what you got. The other stuff on this system are obviously something different, as I do already have Mac installed on this. I think I have High Sierra on this drive. But since we put Catalina on here, I think this one should boot into Catalina recovery for us. All right, that whole process to the Apple, you saw the verbose mode on the actual boot. That usually takes about a minute, depending on the USB drive. I'm using a really old USB drive. If you had USB 3s, it would probably go a little faster. But you should expect between 2 and 5 minutes, depending on your speed of your device and internet connection, as I think some of this does download through the internet because it is recovery. However, if you do use pre-built SSDs, like in the very beginning, this will take longer. All right, and we're ready to go. On the language section, if you get one that says Russian, you need to go reread the direction. Make sure you blank out all the KBD type entries. So if you do the troubleshooting section in that thing, you'll see that, hey, it says it in Russian. Go into that config.p list. There'll be something that's KBD. Make sure you have nothing in there. Some how-to guides say, hey, enter a value. You don't want any of that. You blank all that out, and then you'll just get your selection of language on startup. So I did run into that problem initially. All right, so then here we are. First thing you probably want to do is disk utility, and you want to wipe out your entire disk. Make sure you say when it comes to partition, which I'll go ahead and pull up here, you'd select your base disk. Sometimes you'll have a partition underneath that. Make sure it says base disk here. And if it doesn't, you'll just need to go view, show all devices, and then go up to the actual internal drive. And then you're going to want to erase this. And then under format, you just select macOS extended. And then under the scheme, you need to make sure it says GUID. A little tricky there at the very beginning, but just know that that's what that does. If you have issues with it saying MS-DOS mode, just make sure you go to view all devices, and then you can get past this portion. That's where some people get tripped up. So with that, we'll close out, and then we could install macOS. But from here, you could easily continue in. I'm going to go ahead and reboot into my actual desktop, and then showcase some of the update capabilities of macOS when it comes to using OpenCore. Now on startup here, you'll notice I left the OpenCore boot menu. We could go into our system and modify some of this so it doesn't look like this, as this might freak some people out. So let's go ahead and modify our EFI on startup here so we don't see all the things we've just done. So as you see, I've actually been using this Mac a little bit. Now, Mount EFI Update is a GitHub project as well, which you can look up on the web. You'll notice this is where I grabbed it directly from the GitHub, Mount EFI. Obviously, I don't need to re-download it, but I thought I'd just show you where it's at. And then we're just going to run this command. And we're just going to mount our EFI, put our Apple password in, and quit out. From Finder, you'll see that we now have an EFI device. This is all the debugging and startup from this system. So if we wanted to, we could. So that was a very long video to make. I apologize for the length of this, but at the same time, this was needed. Like, I didn't want to chop this up and do like a 2 weeks worth of macOS videos. That's why I did the timestamps at the bottom, and you could follow along easily. And that way you could come back to certain parts of the video as well. As this project is probably the best project I have ever seen when it comes to macOS. So clean, well documented, run by brilliant people. I have nothing but fantastic things to say about it. But let me know your thoughts down in the comments section below if you made it this far. Because, wow, I absolutely love this. I just want to install Mac on a whole bunch of hardware now. And I actually am. I'm installing it on my laptop inside once my Wi-Fi driver comes in. Or my Wi-Fi card. So with all that, a big shout out to all my patrons. Without you, I couldn't make videos like this one. And I'll see you in the next one.